Okay, conditional statements. So let's look at what a conditional statement is. First of all, it's just taking a statement, which is a sentence, and writing it in if-then form. Adding the word if at the beginning, then in the middle to separate it into two parts. And we symbolize these with P and Q. The first part of that statement, the P, represents the hypothesis. That is the if part, but look at the definition. It's the phrase following but not including the word if. So it's the part after the word if. The second part of that statement, the Q, is the conclusion. It is the part that is following the word then. So if we look at this first statement here, if you have no more than 2 absences and a B average, then you can exempt your final. Well, my advice would be to box, circle, or highlight the word if and then. The part following the word if is your hypothesis. The part following the word then is your conclusion. Notice I did not highlight the word if and then. It just helps us identify which part is which. So the if part is the hypothesis, the then part is conclusion, but we don't include those 2 words. So in this one, they want us to rewrite the statement, making it into a conditional statement, meaning we need to add the words if and then. And so then we can state the hypothesis and conclusion. So if we look at this statement, a car with poor brakes is a menace on the highway. We could add the word if and then by saying something like, if a car has poor brakes, then it is a menace on the highway. Notice we took out the word with and added the word if a car has poor brakes, and that's okay. You can't change it to say if a truck has poor brakes or if a car has good brakes. You can change just those little words. So we would say here, if a car has poor brakes, then it is a menace on the highway. Remember, we're going to identify the hypothesis and conclusion by locating the words if and then. The part following the if is your hypothesis. So I'm going to highlight that to color code it. And then your conclusion is the part following the word then. And I will color code that in green. So again, hypothesis is the part following if, conclusion is the part following then, but we do not include those 2 words into our actual statements. Okay, so now what we could do is take conditional statements and we could rewrite them different ways. The first way is to talk about the converse. The key word for converse is switch, and so I want you to add that here. Meaning we take the hypothesis and conclusion and we literally switch them. If and then aren't going to switch. It's like they're glued in concrete. They are going to stay put. But the hypothesis and conclusion, we will switch places with those. And notice over here, the symbols, they switch from P to Q to P. Inverse, the key word, is to negate. And we know that negate up here says add the word not. And so that's our key word for inverse. We're just adding nots to both the hypothesis and the conclusion. The symbol for negating or adding not is this little squiggly line. So if not P, then not Q is how we would say that. Contrapositive is a combination of both of those. We negate and we switch. So here is our key word here. I would just put both, or we could write switch and not. So we have to do a combination of both the converse and the inverse. And notice the symbols here. If not Q, then not P. Okay, so let's practice rewriting those equations here. So let's start with example 3, then we'll go back up to that vocabulary word of counterexample in just a minute. So the statement that they're giving us is, if you play football, then you're an athlete. So again, we want to locate our hypothesis and conclusion. So there's if and then. The part following the if is the conclusion. The part following the then is the the part following the word if is the hypothesis. The part following the word then is the conclusion. So our hypothesis is the P, you play football. The conclusion is the part after the then, the Q, you are an athlete. Okay, so what they want us to do here is they want us to do the converse, inverse, and contrapositive, taking those sentences and rewriting them. Remember, converse is to switch. We're not switching the word if and then, we're switching the hypothesis and conclusion. So we would say here, if you are an athlete, then you play football. So if you are an athlete, then you play football. Okay, we switched the hypothesis and conclusion. Inverse means to add the word not. We cannot add not to just one part, we have to add it to both. So we would play, if you don't play football, then you are not an athlete. So if you don't play football, then you are not an athlete. Okay, so you have to add nots to there. If there was already a word not there, then you would take it out. You wouldn't say not, you would just, those kind of like with negatives. Two negatives cancel out, make a positive. Contrapositive is where we switch and add not. So my advice is to look at the converse because it's already switched and add the word not to that. So we would say, if you are not an athlete, then you don't play football. Okay, so we can now see that we switched for converse, we added nots for inverse, and we did both for the contrapositive. Now what they want us to do is tell the truth value of these. And this is where we get into, I know it doesn't look like math or geometry, but we can start to add in geometry statements and tell the truth value of those. And so we would look at the first one and say, okay, if you play football, then you are an athlete. Well, if you play football, then you're considered an athlete because you're in athletics. So that is true. The next one, converse, if you are an athlete, then you play football. So what this is saying is, if you're an athlete, then the only sport you play is football. Well, that's false because you could play other sports. And that's where we get into our counterexample here with this definition. A counterexample is an example that shows why a statement is false. And so you cannot just say, well, they don't play football. That's not the only thing. You have to be very specific. Counterexamples are very specific. It's not a because I said so moment. It's not a because this happens. It has to be super specific. So if it says, if you are an athlete, then you play football, well, that's false because you could play basketball. That would be a counterexample. Okay, so then let's look at the inverse. If you don't play football, then you're not an athlete. Well, it's kind of the same scenario here. If you don't play football, you could still be considered an athlete if you play another sport. So that one's also false. We could use the same counterexample, or we could use another one. I'll go ahead and use tennis as an example, just another sport. And then the last one with contrapositive, if you are not an athlete, then you do not play football. And so that one is true because if you're not an athlete, then you're not in sports. And if you're not in sports, then you're not playing football. If you state the statement as true, then you do not need a counterexample. Counterexamples only occur for false statements to prove and justify why something is false. Okay, now look at this for a minute. If we go back to our chart, we can see that our conditional statement was true and our contrapositive was also true. These two statements will always have the same truth value. If the conditional is true, the contrapositive automatically is true. If the conditional is false, so will the contrapositive. They will always have the same truth value. So you don't really even have to look at the contrapositive and read it. You know it's going to be the same as the conditional. Same thing goes for the converse and inverse. They will always match up and be the same. If the converse is false, the inverse is false. If the converse is true, the inverse is true. They always have the same truth value. Okay, so let's look at this one really quickly. We know that given the conditional statement, our hypothesis, our P, would be here at an angle has a measure of 120 degrees. The conclusion, the part following the word then, our Q, would be it is an obtuse angle. So just to recap, I'm not going to write all of these out this time. Converse means switch, so we would say if it is an obtuse angle, then it has a measure of 120 degrees. Notice I made a few little changes just to make the statement sound better, and that is okay. As long as you don't take the true meaning from it, you can make a few of those switches. Inverse means to add the word not, so we would say if an angle does not have a measure of 120 degrees, then it is not an obtuse angle. Contrapositive, again, is the combination of both. We need to switch and add the word not. So if it is not an obtuse angle, then it does not have a measure of 120 degrees, would be that statement. So now let's practice the true-false part and the counterexample only if it's false. So let's look at the conditional. If an angle has a measure of 120 degrees, then it is an obtuse angle. Well, that's true. If it's over 90, then it's considered obtuse, so that's true. But remember, we said on the last slide that the conditional and contrapositive will always have the same truth value. So if that is true, this is automatically true. Now, that doesn't mean that the other two are false. They can all be true, they can all be false, you can have a combination. You have to look at them separately. So let's look at the converse. So if we switch it, if it's an obtuse angle, then it has a measure of 120 degrees. Well, if you make that statement, you're saying the only measurement an obtuse angle could have is 120 degrees. And that's not true because you could have anything from 91 to 179. So we would say false, and to be very specific for our counterexample, anything in that range. So we could say something like 95 degrees. 105 degrees, 170 degrees, any of those would work as a counterexample. So again, if the converse is false, then the inverse is false, and you could use a counterexample the same, or you could change it up a little bit. Sometimes you only have one counterexample, and that's okay. It only takes one statement to prove these false. So if it's just one reason why it's false, then it's automatically false. Okay, so let's just kind of recap on this one. Remember, P stands for hypothesis, the part following the word if. The Q stands for conclusion, the part following the word then. Conditional means we just add the word if and then. Converse is a switch. Inverse is a not. And contrapositive is a combination of both. Remember that this one, the conditional and contrapositive, will have the same truth value, and the converse and the inverse will always have the same truth value. So if they're false, that's when you provide a counterexample. If they're true, you don't need one. Okay, our last little bit of this is the word conjunction, disjunction, and biconditional. And so a conjunction, the key word for it is and. That's the word you look for. To say that a conjunction is true, both parts of the statement have to be true. The first part and the second part both have to be true for you to say that that conjunction is true. The key word for disjunction is or. This happens or this happens. Only one of those parts has to be true, but they can both be true. But you have to have at least one being true. This could happen or this could happen. A biconditional is when we say if and only if between these. And for a biconditional to be true, it has to be true both forwards and backwards. And so we'll look at some of those examples down below. So if you look at the first sample, I see triangles have 4 sides or pentagons have 5 sides. Well, the key word that I see here is or, making that a disjunction. And so this junction is true because the first part is false, but the second part is true. So a way I would do this, if it's or, I would say this is false, this is true, but because it's an or statement, as long as I have one true part, then the whole statement is true. The next one is a triangle is equilateral if and only if the 3 sides are congruent. So this is a biconditional. We kind of have to look at it forwards and backwards. So a triangle is equilateral if the 3 sides are congruent. True. 3 sides are congruent in a triangle if it's equilateral. So both of those ways are true, making this biconditional true. The last one says fish swim in water and 3 plus 3 equals 5. So let's look here. Fish swim in water. Yes, that's true. 3 plus 3 equals 5. That's not true. But for it to be a true and statement, a conjunction, both parts have to be true, and so this part is false. So let's practice some of these for a minute. So again, look for keywords. Let's go ahead and tell what type they are, and then we'll look at the true-false part of it. So the first statement here is perpendicular lines form right angles and right angles measure 90 degrees. So anytime we see the word and, we know that that is a conjunction. The next one, mice chase cats, or 2 times 5 equals 7. Well, I see the word or, so that is a disjunction. Okay, next one, alternating interior angles are congruent if and only if parallel lines are cut by a transversal. That is a biconditional. We see if and only if. Rectangles have opposite sides congruent and also have opposite sides parallel. That is a conjunction with and. 1/2 equals 50%, or a straight angle contains 360 degrees. That is a disjunction. A triangle is a triangle if and only if leg 1 squared plus leg 2 squared is greater than the hypotenuse squared. That's a biconditional. Next one, a numeral 102 is read 102, or 50 cents is written as 0.50 cents. So or means we have a disjunction. I wrote the wrong letter here. Sorry about that. That should be a B for biconditional. Okay, so again, if it's an and statement, both parts have to be true, or statement, at least one. If and only if, we will kind of look at it forwards and backwards. So the first one, perpendicular lines form right angles. That is true. Put a check mark with it. Right angles measure 9 degrees. Check mark. If it's and, both have to be true. So that is a true statement. The next one, mice chase cats. Well, that's the opposite. Mice don't chase cats, so that's false. 2 times 5 equals 7. That's false. For it to be a disjunction, we just need at least one. We don't have any, so this one is false. This biconditional, alternating interior angles are congruent if parallel lines are cut by a transversal. That's true, so that first part's true. Alternating interior angles are congruent only if parallel lines are cut by a transversal. That's also true, so that is a true statement. Okay, next one, we have another and statement, so they both have to be true. Rectangles have opposite sides congruent. That's true. They also have opposite sides parallel. Those are 2 true characteristics for a rectangle, so that conditional is, that conjunction is true. Next one, 1/2 equals 50%, true statement. A straight angle contains 360 degrees. That's false. That should be 180. But because it's an or statement, a disjunction, we only need one, so that's still considered a true statement. A triangle is a right triangle if leg 1 squared plus leg 2 squared is greater than hypotenuse. Well, if it's a right triangle, we know Pythagorean Theorem to be a squared plus b squared equals c squared and not greater than. So that right there doesn't work, making this biconditional automatically false. We don't have to continue thinking about it. And the last one, the numeral 102, is read 102. Well, we know that if we add the word the and, that's a decimal, and it doesn't say 100.2, it says 102. So that right there is false, but it's an or statement, so let's check out the next one. 50 cents is written as 0.50 cents. Well, if they have a decimal, that's money, and we need the dollar sign. And so if it has a cent sign, we would take the decimal off, and so that part is false, making the whole statement false. So I know this looks a little odd for math in general, but this is using logic, taking our statements, and especially with these statements, talking about squares, looking at the converse, inverse, contrapositive of our definitions, and seeing if they work every single time. Will they work if we switch it? Will they work if we add the word nots? Same thing here. We're looking at our different angle measures. So taking our logic throughout the year and looking at statements, whether it be the